Hello everyone, this is Corbin Moss. I'll be going over the exercise 7 exercise. And so first it wanted us to, with using the employee attrition data set, build a logistic regression to model the predict employee attrition. So as we can see, going to roles, we have the responses attrition and some continuous effects. So the measurements such as age, job satisfaction, job involvement, work-life balance, year since last promotion, distance from home, and environment satisfaction. So looking at the model equation, we're going to maximize going to perimeter estimates. And so we're going to do the 3.45 minus 0.05 times age minus 0.28 times job satisfaction minus 0.49 times job involvement minus 0.26 times work-life balance plus 0.005 times years since last promotion plus 0.025 times distance from home and subtracting 0.27 times the environmental satisfaction. And then as we can see, we have a very low R-square, and even looking at this, we can tell that only 7.25 of the data is going to be reliable to use, so it does not perform well when interpreting the attrition. And then as we can see some outline characteristics over here. To delete these, you're able to just select, right click, and remove data. But at the time, we're not going to do that. We're just pointing out the outliers and the outlying observations that could cause a concern. Next, it wants us to recreate the logistic regression from 7.1 and create a generalized linear model. So right here, as we can see, we're looking at years at the company, and the continuous effects are going to be age, job satisfaction, years since last promotion, and environment satisfaction. And the classification effect is going to be attrition. So as we can see, job satisfaction has the lowest p-value. Has the highest p-value. And since going back here to AIC, we can see that this also is not a good use of the characteristics that we have put into the roles. And now we're going back to exercise 6. So as we can see, it wants us to recreate the house price regression model from chapter 6 using a generalized linear model. So as you can see right here, we have this, and moving from right here, we have the linear regression as sales. And moving to roles, we have the continuous effects of TV, radio, and press, and an interaction effect of radio and TV. Moving over, we can see we have the same response, continuous effects, and interaction effects. So when looking at the ASE, we can see that these have the same ASE, so they represent the same characteristics and have the same output. And going to options, it wants us to go to general and look at the distribution, and as we can see, it already is in normal. And with the link function, we can see identity, changing it to log changes the data, and then changing back to identity is going to give us the best prediction of each. And as we can see, moving through these, the ASE, the AIC, and that is going to be the end of exercise 7. Thank you.